Hi everyone, welcome to another edition of the live stream for Azure API Management and Azure API Center. Today we are going to cover some of the exciting updates and have a Q&A session. In the meantime, if you have any questions, please also post them in the comment section and I'll keep addressing those as we go. This is the last edition for this year, so I'm especially excited to be here with you. Just to remind, what is the purpose of those community calls that we are organizing now every other month or so? First of all, it's a way for you to hear our opinions on the direction that the API industry is headed in, see what's new in our Azure API platform, including Azure API Management, Azure API Center, and some of the products around it, and how you can leverage those new developments for your own benefit. You can also ask questions about our products or provide feedback. We are closely monitoring the chat. And also, you can connect with some of the other attendees so you can learn from each other how you use API management products. Today, as I said, we have an exciting agenda. So first, we're going to have a guest speaker, Darrell Miller, to talk about a new rate limit header proposal. And then we are going to dive deeper into the Azure API platform updates, including workspaces in API management, policy toolkit, premium V2 tier, GenAI gateway capabilities, as well as API Center updates. With that, I would like to hand it over to Darrell Miller. Hi, Darrell.
Hey, Mike. Thanks. So yes, today I'm going to talk about a proposal that is in the IETF going through the HTTP API working group. So to start it off, let's talk about what is actually out there today in the world. So if you can move to the next slide. So what you will see in a bunch of different popular APIs out there is this X dash rate limit, rate limit remaining, and rate limit reset. And this is what a number of sites do, but a lot of them do it slightly different. And there are some variations on this in both the syntax of these headers and semantics. Next slide, please. So when the proposed document first came to the IETF working group, the idea was just to standardize really what was out there, get rid of that X dash off the front of it, but continue with the three headers containing both the quota, what the remaining were, and how long until the thing was reset. And the goal was to really maintain compatibility as much as possible. But as more people got involved with the conversation, we saw a lot of other opportunities for improvement. And one of the things that was suggested was adding this additional policy information. So you can see this at the bottom. There's, if you want to do kind of a sliding window, you'd be able to say, use parameters on the limit to say the sliding window is 10 seconds. And so that was added. However, the working group decided that there was enough opportunity here that just taking what was out there and just basically rubber stamping what was there was probably not the best step forward. And there's also a lot of work at the moment going on with headers to try and standardize their syntax into what we call structured header fields. And so this was the next evolution. The idea was we'll just have two headers, one which actually defines the limit that you have at this point in time, and then using this dictionary of key value pairs to say this is what the amount of the limit is, this is how much is remaining, and this is the reset value, and having just a policy field that can tell you overall, this is either your daily policy or your hourly, or if you want to have something that stops spikes, you can do a different policy. The challenge with having, if you want to just go back a slide, the challenge with having the different kind of limits is you're never quite sure which limit that is actually close to being expired. And so this is why we introduced this identifier, this named policy. So now you can actually correlate, hey, this is my daily policy. This is the name that I give it. and here are the overall parameters, and then the rate limit would just tell you what you have left for that particular policy. And so with having that name, you're able to get headers for multiple different policies, and you know exactly which one it is correlating with. So now we can go to the next slide. We also had requests. Well, we don't necessarily just want to limit on number of requests. There are other units that you might want to use. And so we introduced a registry for different types. So we have content bytes as currently one of the proposed limits, and also concurrent requests. With this being a registry, we have the opportunity in the future to add other things in there, like maybe tokens or some arbitrary thing called cost that can be used in order to measure how much quota a particular request consumed. We can go to the next slide. So it's all well and good to be able to have services that return these headers. But really, what is the purpose of it? The purpose of these headers are to allow a client to be able to read those headers and back off so that they don't hit the limit, or adjust traffic shape their own calling patterns in order to be able to avoid hitting those limits. And what we discovered is, while there are lots of services that return these headers, there's really no generic tooling out there, or very, very little, that can actually process these headers. And so what it ends up is, everybody who wants to go and actually do any kind of traffic shaping has to go and write the code specifically. And often it's very specific to a particular service, because the way that the quota is divided up is very different, and it's kind of application specific. And so we are introducing a new concept called a partition. If we move to the next slide. So the idea of a quota partition is that it divides the service capacity off different things. Could be clients, could be users, could be resources. And this is something that already exists over on the server side. It's just not something that we've ever communicated down to the client. And so in this case, now we are using this new PK property that allows you to return back an identifier that says, this is the rate limit available for this particular partition. And what this does is it allows developers to now produce a more generic code on the client side that you can just reuse in order to be able to do your traffic shaping on the client. Next slide. And so now we have the ability for clients to be able to determine how to generate these keys. And this will, how to generate the keys will have to be kind of shared out of band. Like, you'll have to know for a particular service how that partition key is generated. Is it based on the user? Is it based on the app ID? What part of the URL is it based on? And it is possible that generic clients could get really clever and use heuristics to be able to predict keys. Hey, I've made this kind of call a whole bunch of times and I'm getting the same partition key back. Therefore, I believe that in the next call I make, this is probably what the partition key is going to be. And then over time can figure out dynamically what the rate limits, which partitions the rate limits particularly apply to. If you go to the next slide, here's an example of just a little bit of code that I wrote that was kind of, it's an example in Python of how you might take a request and then say, okay, well, I'm going to use the method as part of the partition key. I'm going to use the first path segment, and then I'm going to go and look into the token, and I'm going to use the subject, potentially the user, and then glue that together, and that's the partition key that is appropriate for this particular service. And then that will then allow me to know whether or not I have quota left for that particular partition. Next slide. And so this is still a work in progress. We are getting much closer to the goal, but we are still looking for feedback, and anybody can participate. We want to know, like, you'll see the name of that policy was quoted before, and there's an option to not make it quoted. Is that important? Is it not? Not sure. What is this initial registry of quota units? As I suggested, we put a few in there, but maybe there's some ones that we're missing. And do people really feel like this partition key is going to be able to solve the problem? Can we actually communicate that format of the partition key in band so that you don't have to know in advance? It's something that we could explore. And do we need that partition key on both the policy header and the rate limit? These are the kind of questions that we're exploring at the moment. With regards to APIs, there are a lot of other specifications that are going through the IETF HTTP API working group. And so if you're interested in any of these other things, we're always looking for feedback from people who participated. And with that, thanks.
Awesome. Thank you, Daryl, a lot for your content here today. Can you tell us a bit more, what is the path forward of this proposal? I know you're looking for feedback, but how do you foresee the timelines and the steps?
So the way it works is we have there's a mailing list, there's a GitHub repo where people can file issues. We continue monitoring the issues that people are raising, and we identify whether we need to go make docs based on those issues or whether they can be just resolved without any changes. And when we get to a steady state where we are not getting new issues being filed, or we're just basically rehashing old conversations, we'll go into a phase which we call working group last call, where there's a period of 2 weeks where people are given like a last chance in order to provide feedback on it before it then goes up through the hierarchy of the IETF, where there's a layers of area directors and other people who've spent a lot of time working in the specification work, who will provide more generic feedback just on the clarity and editorial content. And once it's through working group last call, it generally takes a few months to go through the IETF machinery to actually be published as a specification. So we're probably looking at working group last call probably in January or February next year, and middle of the year for publishing it as an RFC would be my guess.
Awesome. Well, thank you very much, Daryl. It's exciting to see, hear the news from the bleeding edge. It's something that's, very early in development, might be launched in the next few months or maybe a year or so. And, have an opportunity to shape all of this. It's extremely exciting. And thanks for sharing all the news.
Yep, very welcome.
All right, now a few updates around the workspaces in Azure API management. Just to set the stage and remind everyone, in the API ecosystems, we typically see two kinds of teams that collaborate with each other. There is an API team or a set of API teams that develop, debug, monitor, and manage APIs throughout their lifecycle, as well as related resources, such as certain keys, values, policies, etc. On the other hand side, we have the platform team whose main responsibility is to set up and manage the infrastructure and the platform for API teams to utilize in order to manage their own APIs. The platform team also, in many cases, wants to audit or enforce API compliance, whether it's with organizational rules, security rules, or some regulations, whether geographical or industrial regulations, as well as monitor traffic and platform usage to see how the teams utilize the platform to publish their own APIs, as well as what the API traffic in the platform looks like. In some cases as well, the platform team is interested in splitting the cost of the platform among the teams that utilize the platform to publish their own APIs. Previously, API management supported centralized and siloed API management models. In the centralized model, all the teams collaborate on the API management service without any isolation of control or data planes, potentially causing issues in both planes, as well as causing the platform team to become the bottleneck in managing APIs and resolving all these conflicts among the teams that arise in control and data planes. So an example could be, for example, a team takes a dependence on another team's resource, and when that resource changes, it causes an outage for other teams' APIs. Or in the data plane, when all the APIs are packed on one gateway without any isolation, one API may cause exhaustion of resources like CPU and memory, bringing down the whole API gateway and all the APIs in the portfolio. The siloed model is sort of the opposite, where each API team is given their own API management service, where they manage APIs with full isolation of control and data planes. But this model is very hard to apply governance for the platform team, or centralized monitoring, or centralized API discovery. So with a federated API management model, you gain the benefits of these previous two models without their downsides. And the way it works is that each API team gets a portion of their own portion of the API management service with isolation of control plane and potential data plane, making sure that they can manage their own APIs independently. But since it's still a single API management service, that means that all the API governance is relatively easy with the controls that we already offer today. The API discovery can be unified with the developer portal, and the platform logs can also be centralized. Workspaces in Azure API Management enable that federation of API management through isolation and governance controls. So the isolation can happen on the control plane. It happens on the control plane, where you can think of workspaces as sort of folders that you can assign permissions to, and APIs are managed within those folders, within workspaces, with a proper set of permissions to a proper group in your organization. One team may not have access to another team's workspace, and vice versa. On the runtime plane, you can use gateways, workspace gateways, to isolate certain workloads from each other, especially the workloads that are mission critical, to avoid that resource exhaustion issues, the noise neighbor problems, or even reducing the blast of cybersecurity incidents. That removes the API gateway being a single point of failure for all of your APIs in the organization. On the platform team controls, we do offer all APIs policy for enforcing API runtime compliance, as well as monitoring and developer portal for API discovery that spans across all workspaces in the API management service. If you're new to API management, this is a diagram what you can think about workspaces in terms of architecture. So on the service level, in the API management service, you have a developer portal with APIs policy, logs, and metrics, and then you have a set of workspaces, and you assign permissions to a workspace to a specific team, and this is where the team manages their own APIs, products, subscriptions, named values, policies, etc. Then the workspace is associated with a gateway resource, with a workspace gateway resource that sits outside the API management service, a separate Azure resource. And that gateway resource has configuration like scale, hostname, networking, or some TLS settings. What's new as of Ignite, a couple of weeks ago, we just announced shared workspace gateways. This capability allows you to associate up to 30 workspaces with a workspace gateway to federate API management at a lower cost if you don't need a full isolation of the data plane between workspaces. We offer you this functionality, but you have to keep in mind your business requirements and balance reliability, security, and cost. So, for example, we recommend using dedicated gateways for mission-critical workloads to make sure that APIs from other workspaces don't affect your mission-critical workload. So if you have a mission-critical workload, you can deploy that mission-critical workspace on its own dedicated gateway that's not shared with other workspaces to avoid issues like exhaustion of CPU, memory, or other resources caused by other workspaces. For non-critical workloads, you can use the shared gateway functionality to optimize the deployment cost of the platform and reduce effectively the cost of workspace deployment. You can also use distinct gateways for different networking requirements or use cases. For example, you can use one gateway for internal API traffic and the other gateway for external API traffic. And those gateways can have different networking configuration depending on how you expose those gateways. And this functionality has been announced. You can learn more in the blog post on the right-hand side. It will continue to roll out through December, January, and possibly parts of February. So stay tuned and give it a shot, give it a try once it's available in your service. With that, let's move on to the other side with Rafael.
Hi, hello. I will be talking about the policy toolkit. So this is a project which I was working for some time now. And let's go and say, what is the policy toolkit? So policy toolkit is a set of libraries and tools to help developers and help developers, especially of policies, to do work better, faster, with consistent syntax, with your inside your IDE, which you like the most, with the unit testing of the policies locally. You do not need to run to the API management and run it inside. And as well allows you to integrate like all the tests and like creation of the documents inside the CI/CD pipelines. And let's maybe best go to how this toolkit can look like and what you can do there with a demo. Let me say first, like, let's write the policy as a write policy to some API where we want to like to authenticate internal customers with some from some IP addresses in one way and from outside another way. So firstly, on the left side, you can see I started to write, like it's recorded, but we write the C# class where we have all the information about like the sections, and as well like this isCompany method is the expression which we will have in the policy. In there, I just write the normal C# code in the inbound class with if statement. When I execute this expression, then I can execute like context, authentication basic, and placed named values. In the second else, I can do the authentication manage identity with some resource. As you can see, I finished the writing, and on the right side, I have it compiled to the XML class, XML state, which can be applied to the API instance. But here is the biggest thing what you can do. You can test stuff in there. So for example, here on the left, I'm now writing a test to the expression. So I'm creating a mock expression context, give initial values, and then I will run it against the code which I wrote before and test the result there. So in this case, I have like two state data rows, which I write the internal and external IP address, and let's see if it works. So at the bottom, you can see like the test was written, and that's it. So that's basically what all of it you can do. But lately as well, we were working on one more thing here. We'll be able to like deploy our policy to the instance through our extension. So I just open the one of the instance, one of the policy, applied it through the IDE, and done it everything inside VS Code. So like I said, there is as well another thing which lately we're working on is testing the whole policy section. So here I will write a small test where I will check if header, authorization header will be either basic or bearer. And this is how we prepare it. So you create your document, you create a class which is a test document, which gets the document which you created. You add the all of the stuff like the initial state of the request, and then you run the test against the like one of the section. In this case, it's just a run inbound. Then we can inspect the test, inspect the context, and check if things are there. So in this case, I'm checking if there is a header authorization, that I'm taking the value from it, and test if this value starts with my expected token. So in this case, it's either basic or bare. So I can again run the test. You should see now the 4 elements there. So yeah, it's 4 passed. And now I will use the built-in debug debug functionality to show you that there are, in fact, some values there. They are mocked, in fact, but they are. So in here, I should show you that, yeah, this IP address 10.001 will produce for us basic authorization with the encoded token. And next, when there is external, so this 12.001, then the token is in fact the JWT. In this case, it's just some mock data there, but it is created. And yeah, and that's all from the demo. Please check it out, the repository. Please, if you check it out, try it out. We will be happy to hear it from you. If you want as well to contribute, the thing is open source. So whatever policy you would like to implement, because not all of them are implemented, or you would like to contribute to the testing, please go there and help us out.
Awesome. Thank you, Rafa. It's fantastic to see how now we can easily author all these policies in C# and unit test them without even leaving VS Code or your IDE of choice.
Yeah, that's very cool. Like that, you can do it like everything on your machine. Like you don't need to like send it anywhere and do it.
Right. It's such a convenience, major convenience. Right. Thank you. And now I will jump into the section about Prim V2.
Hello. Right here. Slide.
Shrikant, you're having some audio issues from your side. It's breaking a lot.
Oh, okay.
Oh, I think it's better now.
Yeah, we announced the public preview of Azure API Management Premium V2 tier at Ignite 2024. Premium, as you all know, offers the highest capacity, highest entity limits, and also the most comprehensive. It's better than new architecture. It eliminates all the dependencies, the ports for internal Azure dependencies and things like that. Sign up for the next slide.
Sorry, we couldn't hear very well, Shrikant. I think audio issues again. Maybe I can briefly cover for you here. So we heard about the limits. We heard about the new architecture in the VNet that eliminates some of the dependencies that are required in V1 tiers, making the VNet configuration more secure and better for our customers. And the public preview is available in the regions listed on the site, and you can sign up using this link at the bottom of the site. And maybe if you can talk a little bit slower, Shrikant, make sure that we hear your audio correctly.
This diagram essentially, okay. So this diagram essentially shows how the VNet injection is different between the classic tiers and V2 tiers. What essentially it shows is how with the new architecture, as what Mike was mentioning, there is no need to open the traffic to other internal dependencies like storage, SQL, and Azure Monitor, and it gives you complete network isolation. So looking forward for you to sign up to the preview. For the next slide, Mike.
Perfect. Thank you, Shrikant and Andre and Chris. Would you like to come on the stage?
Sure. Thank you, Mike.
Awesome.
So in the next couple of slides, I just want to share what's new in GenAI Gateway capabilities and Azure API management. So first of all, just to recap, what are the GenAI Gateway capabilities and API management? So that's essentially a number of features to help you manage open APIs, right? We have features such as token-based limiting. We have load balancing, which can help you load balance across multiple OpenAI instances. We have semantic caching and more. So what is new, which is coming approximately in January or February timeframe? So first of all is we're extending the Azure OpenAI token limit policy. So now instead of just saying that, okay, I want to limit per minute, tokens per minute, now you can also assign long-term quotas, which can be per hour, per day, per week, per month, and even per year, which kind of gets you more flexibility on how you can manage the cost side of OpenAI tokens and OpenAI consumption within your organization. And the next, this is a long-waited ask. So we are introducing support for GPT for all. So recently, you were only able to use text-based input with API management with all of the policies that I mentioned previously. Now we also support images. So now you can use full features of GPT for all with API management. So these are the quick updates. All of them are still not there. Just wait a little bit. They're coming in January, February timeframe. And next section is, so we essentially have a lot of different resources when it comes to using API management and GenAI Gateway capabilities. And one of the great resources that we have is the sample app that utilizes a lot of features that I mentioned previously with this simple chat application. But let me hand it over to Chris to tell you more about the sample.
All right, Andre, thanks so much. Hope you can hear me well. I'm calling in from London, Paddington, so excited to see if there's any UK folks on the stream. So yes, as Andre was saying, we have a great resource in this API management sample. You are getting quite a few things in there. Managed identity, of course, for enterprise level authentication and authorization. Load balancing, we all know how important it is to be able to scale. Circuit breaker, because you want to be able to manage all of those errors when they happen and have some great policy for that. And then, of course, here's the great reason why GenAI and APIM is such a great match. You got the token limit and the token metric. But before we go into those, I just wanted to show you that one of the reasons that I wanted to talk to you today is I wanted to talk about what it's like in production. So, and we all know that production means infrastructure as code. It means encoding it in either Bicep or ARM templates so that you easily can create your cloud resources. So what I'm about to show you are how to define policies, how to create cloud resources, how to organize your Bicep files as modules, and also get a sense of how do I even start? What's my entry point? And the answer here is main Bicep. And yes, so can we go to the next slide, please? Right, so this is one of those policies that makes it such a great pairing, APIM plus GenAI. We have something called token limit. It can help us a lot in the sense that it can limit how much tokens are being used by apps. So we can set metrics, we can set attributes that actually stops it from over-consuming. It also helps us with a phenomenon called the noisy neighbor, when one application or several applications are using up all the resources and the other AI apps that you have running won't get any. And of course, there are a few interesting attributes as part of this policy. Counter key, how you want to track things, tokens per minute, how much you want to restrict, and also how you want to estimate prompt tokens. I believe we have some token algorithm that can figure that out. And then we have the retry after. I believe we have two different flavors, but what's important here is the attribute called tokens per minute, essentially how often it should try to retry, and this is measured in seconds. So we can advance a slide, please. Right, and this is the other bit that I'm super excited about, because we all want monitoring, right? We want to have a sense of how much are people using our apps. So we want to be able to track and have this really nice graph here. So you can see we can track usage, and so we can understand usage and cost. There are a few cloud resources that we need to create, though: log analytics, application insights. But then you will get this sweet looking dashboard, so you can have all these dimensions that you measure it by. And if you look here at the bottom, you see how I've defined this as part of a policy, where I have dimensions like subscription ID and another dimension where I'm tracking it by client IP. This is something that you then can group by as part of your dashboard, so you can get that insight. How are people using my AI apps? So if we can advance a little bit. Right, so now we come to the demo. So Mike, could you please roll the video for that? Right, and I think we're running. Yeah, as Andrew was saying, we have some great features in here for you. So APM plus GenAI is a really good idea because we have these token-based limiting, we have token-based quotas, we have load balancing, semantic caching, and also best practice managed identity. And for those of you who don't know what semantic caching is, it's all about making sure that we are returning you with a cached response instead of it actually going to the AI endpoint. And the way we do that is to figure out, okay, here are two prompts that are similar. If they're similar, return with a cached response instead. And just, yes. So the next bit here I want to talk to you about is how this works. Because once you create this in Azure, you're going to create an APM resource and an APM API resource. Once you do that, we create something called backends. So you put up a backend for each of your AI endpoints. And on top of that, you are creating a load balancer. And you can have as many backends as you want, so one per API endpoint. And that really allows you to scale. And all of this is defined within the same resource group. And you can see on the right side here how we have a policy. And what we need to do as part of that policy is to point out the load balancer. So now we understand we have APM API, and we have circuit breakers as part of all of these backends as well, to make sure that we have this error management behavior, so we make our API endpoints resilient. So load balancer, backends, policy. So please have a check at this recording of the stream so you can see how all of this works. So I want to give you that image of how this looks. I believe we have another part, so we can advance the stream just a little bit in the demo. Yeah, fantastic. Right, so imagine now that I have an Azure OpenAI endpoint and I want to know about token management. Well, one of the first things I'm thinking about is the policy. So here I have the token limit policy, and I've got the one called token metric. So for when we define the token limit, we are avoiding this noisy neighbor, this overconsumption of tokens. And the other one here called token metric is all about monitoring usage and getting that sweet looking dashboard as you saw. I think we can advance a little bit in the video as well. Just a few ticks. Right, but yeah, as I said, you got APM resource, you got APM API resource, and you got the policy. As we all know, we are defining that in APM, and this is where we kind of define the XMLs. But of course, for all of this to work, we need to create the underlying cloud resources for all of these things to work together. Mike, can we advance a few seconds, you think, in the demo?
Yeah, there is no way to advance the video,
okay.
So just
okay, no worries. Okay, so here for the monitoring aspect of things, what you need to remember is the log analytics, but also you need to be creating app insights and dashboards. So 3 different resources that you need to keep track of. Once you have those, and once you have defined these policies in XML and defined all of your dimensions that goes along with it, then you will be able to get this dashboard once you deploy all of these resources. And as I said, encode this in Bicep or ARM or what have you. Now, when it comes to managed identity, there are a few things you need to keep track of, but not that many. What you need to understand is once you create your APM resource, you need to set one of the properties to system assigned. That's great. Another bit here is the policy, in which we need to create a policy called authentication managed identity. Once you have that, great. But then you also have a resource that you need to be creating, because all of your Azure OpenAI endpoint, they need to talk to something that has a specific role, namely the role Cognitive Services OpenAI User. It was a long word. Once you have created that role, and you can create that on various scopes. We choose to create it on the resource group scope, but I believe there's 2 or 3 other scopes that we could be using. But as long as everything is part of the same resource group, you're adding this, you're adding the policy, then you will now be able to use APM plus generative AI in a secure way that works for the enterprise. Right, and now to actually run this demo. So here is the repo that you've been seeing at the bottom right, the link to it. And as you can see, it all contains bicep files, and main bicep, this is your entry point. All the other things are created according to app and core. So you can just go in there, you can browse and see what's going on with the bicep files, and you see how the policies are defined in their own XML file here on the top left side. So this is our kind of best practice, how you organize things so it makes it easier to deploy. And what I wanted to say also about this GitHub repo is it's only a few steps. So you need to log in with ACD, and then once you've logged in, then you can do ACD up. And of course, you've started all of this with cloning the repo, of course. But my point is, you're logging in, you're doing ACD up. And yes, now we're actually seeing this live as we're logging in, and that should only take you a couple of seconds, right, or even less. Once you've done that, you're kind of ready to deploy, and ACD up is how we can deploy. And now we will then put up this application. So give it a few seconds, or actually, I think it takes a couple of minutes to deploy these days. So we've definitely done some nice enhancements in terms of deployment time. So definitely inspect how we've set these properties to make sure that this is really fast. And yeah, so have a look through this README to see exactly what goes on. But I believe it's going to spit out a lot of variables, and it will even populate a file for you, a .env file, which should make it really easy for you to then start up the actual application. So this application has a front end and it has a back end, and that back end is talking to APIM, and APIM in turn is talking to Azure OpenAI endpoints. So here you can see under the source directory how there exist a few things. The backend currently is JavaScript, so Node.js, but yeah, we'll definitely have plans to translate that into .NET and Java and Python, whatever you need. There are instructions in the package JSON that helps you to start the front end, to start the backend. So it should be an easy thing for you to get this app up and running. I believe we want to start by kicking off the API. So npm run start API. And once we have the API up and running, then we can trigger the front end, and you can see how this application will work. So right, so now we're kicking off the web, npm run start web. And once we have that, you will see how you get a chat application, which is, you know, the new to-do app these days. So you see a chat application, and you as a user then type a prompt, and you get some kind of response back. But the response is coming from APIM, and in turn, APIM decides which of the two endpoints that we have will actually respond. And these endpoints are each deployed into separate regions. So the idea there is that you can also see how that would work for you in terms of load. So yes, we start with a simple prompt, with a simple hello. And yeah, tell me a joke, right? We all want to try that with our LLM. And now that we see that, yes, we are being served by the same region, but if you were to kick up this client application in a different tab, I believe it would be served from the other region. But yes, definitely look at this resource. It has everything you need to take it to production, enterprise-grade level security, and is showcasing many of the great features that exist with GenAI plus APIM. Right, so definitely go home, try out this resource. And yeah, I'm just taking it for a spin, so you can also see that, yes, you could use it for conversation, but also for outputting code, whatever you want to do with your time. I believe we have some great call to actions that I also wanted to show you right after this demo, once it's done running. And I think we can go back to the deck at this point.
Yeah, 1 second, technical issues. Continue.
So yeah, I hope you all got excited by seeing that we have this great resource on GitHub. So I do urge you to go in, clone it, fork it today. And with ACD, it's so simple to deploy it. ACD login, ACD up. And there you have it. You have a chat application showcasing many of the generative AI features that we have. Anything you want to add on top of that, Andre?
No, I think that's a great resource. We also have a bunch of other resources. So that's the great starting point. You have chat application, you have APIM set up to work with OpenAI. We also have other resources. We have AI Gateway Labs, where you can like experiment with other scenarios. If you just want to get started, you want to see all of these policies in action and try them out. We also have other resources such as landing zones when you are ready to go production. that's where you would typically start. We have guides, and we also have the landing zone, which is essentially also like a set of bicep files and templates for you to get started and essentially like go production with your OpenAI deployments. And at that point, let's get back to Mike. Yeah, these are actually the resources. So here are the links that you can use. Gateway Labs, as I mentioned, Gateway Guide, and Gateway Accelerator. So, and now let's go back to Mike.
Perfect. Thank you, everyone. Sorry for the technical issues here. Feel free to get started with these resources to check out our GenAI capabilities, and we are heavily adding a lot of new features as well as we go. So keep an eye on this, on our announcements throughout the months if you're interested in GenAI. All right, with that, we're going to go to the last section of this call with Julia Kasper. Thanks, Andre, and thanks, Chris. Hi, Julia.
Hi, Mike. Cool. Let's jump right in. Last but not least, Azure API Center. So we want to use the time in today's community stand-up just to iterate on some of the really exciting Ignite announcements we had a couple of weeks ago. So first of all, one of the really big announcements was around API analysis. Previously, you had to configure your own Azure function to get API analysis up and running. So with our recent announcements, we are just now making sure that all of this is being managed in API Center. So what this means is every API Center comes now with, by default, a managed API analysis set. So you don't have to set up your own Azure API function anymore. It will just work, and you can immediately get started with better API governance. The next one is around a better together between Azure API Management and API Center. So here we introduced a feature called linking or integrations, where essentially from API Center, you're subscribing to an Azure API Management to have better and more seamless integration as before. So essentially, every API that you have on API Management, after you configure the link, will just show up in Azure API Center, so you don't have to worry about configuring a pipeline, setting up any additional things here. Everything, as soon as you connect to API Management, all of the APIs will just show up here. And last but not least, the other very exciting news, where I'm going to show a demo in a little bit, is we announced that we now have an Azure API Center plugin for GitHub Copilot for Azure. And what this flow is going to look like, we're just going to show you in a very quick demo. We are very excited to announce our Azure API Center plugin for GitHub Copilot for Azure. So let me quickly show you what this means from a developer perspective, working with Azure API Center, and how you can use the power of AI for your API development. As you can see, I'm currently in VS Code building out my ASP.NET Weather API. I implemented one controller to get my weather data. With our API Center VS Code extension, you can now leverage Copilot to help you auto-generate the API documentation with just one click. You can see that the auto-generated API specification is generated from my current file, containing all of the necessary information. API Center is all about API design time governance, and as a developer, I want to start thinking about API governance as early on as possible. So let me show you how our API Center plugin for GitHub Copilot for Azure can help you not just only to generate an OpenAPI spec file for you, but also help you generate a compliant API spec. With our Add Azure prompt, I will make sure that we are calling GitHub Copilot for Azure. It will automatically call our Azure API Center plugin, making sure that the API specification generated is already more compliant than our previous AI-generated content. As you can see, this time, my OpenAPI spec already has more information included, making sure that it's already a little bit more compliant. Using Azure API Center, your organization can specify API governance rules and guidelines, unique for every organization out there. So as a next step, I'm going to demonstrate how my API specification
can also align to these guidelines that we currently have in my API Center. So for that, I'm going to set my active API style guide, making sure that this input is being recognized while regenerating the API spec. Previously, I had 4 rules implemented around email information, description, and operation ID. I can now see that all of these rules were taken into consideration, seeing a summary of it at the bottom of my API spec. Now that I have a compliant API specification, I'm ready to deploy my API and register it in Azure API Center. There are a bunch of different ways how you can do this. Today, I'm going to show you how you can use our latest API management and API Center linking functionality. So instead of having to register this API spec in API Center, I can just deploy it to API management directly. I created an asset folder in my current project, ready to deploy this to API management. After deploying this API using my OpenAPI spec to APIM, let's confirm that I can find this API in API management first. I can see my API and my GET operation, and my API admin can now apply API runtime policies on top of this API. Because we link this API management service to my API Center, I don't have to do any further action, because as soon as I switch over to API Center and refresh the API blade, I'm now able to find my weather API also in API Center as a linked asset. Last but not least, let's just confirm on my API governance. Because I made sure my developer is looking at API governance early on, I'm not surprised to find no error or warning messages here because my API is already compliant.
Perfect, yeah. Let's just quickly iterate what we saw in the demo. So as a developer in Visual Studio Code, you know that you need to create an OpenAPI spec asset to either register it in API Center or in API management. So me as a developer being in VS Code, I first of all build out my web API, but then also with the help of GitHub Copilot for Azure, I already made sure in my inner loop that the API specification is already compliant using the information provided by Azure API Center. After me as a developer, I made sure that my API spec is compliant. I then deployed it to API management. And because my API manager has set up the linking functionality previously, I didn't have to worry about register it in Azure API Center. I only had to deploy it to API management. And because of the linking functionality, my API did not just show up in API management, but it also showed up in Azure API Center. This being said, check out all of the resources where you can find all of these things. So we have really great getting started resources. You can also find documentation on APIM, API Center syncing, the GitHub Copilot integration. And also if you're curious to learn more about our roadmap, feel free to check out our GitHub repository as well. With this being said, I'm going to hand it back over to Mike.
Thank you, Julia. Fantastic demo. And it's so great to see so many developer experience improvements with your EI, GitHub Copilot, API Center, API Management, as well as on the policy toolkit that Rafał showed, a bunch of GenAI features and even workspaces to help developers manage their own APIs. So I would say that's definitely one of the main themes of our presentation today. Thank you, Julia, for your session. And please feel free to post any questions you have in the chat. We'll have a few minutes to address them if you have any questions. And in the meantime, please monitor our blog for any product updates, announcements, as well as announcements of these live streams and similar events. So whenever anything comes up, we're going to post it on our blog post, on our blog as a blog post. So feel free to use this link to monitor the blog post. The blogs, it's on the Tech Community platform, and we do post there quite regularly. And yeah, so thank you, Julia. I'm gonna remove you from the stage so you don't have to be in the spotlight. And please take a moment to provide us with feedback on this live stream if the content is what you're expecting or is useful to you. And if you would like us to change anything going forward as we organize this summer events next year, probably every 2 or 3 months or so. I did see quite a few people watching our stream live. I do not see any questions coming in, at least not from YouTube. So if there are no questions, oh, there is a question. Just give me a second. Can you clarify how the API management is deployed for high availability? Certainly, give me a second and I'll post a link to our documentation. So there are several mechanisms for deploying API management with high availability in mind. You should see the link to the documentation in the chat. One of the mechanisms is availability zones. Availability zones basically replicate all your API management components within the same region, but in a different data center. So what it means is that if there is a data center specific outage, your services will remain up and running because there are different data centers in the same region. In case of regional outages, you can use the multi-region feature provided by API Management Premium tier that allows you to replicate your gateways across the globe in different Azure regions. So while the control plane and developer portal, etc., remain in the primary region, you can have gateways in multiple regions, increasing the availability of your API management service for runtime traffic. These are the primary methods used for high availability of API management services. The new one that you can also consider is using workspace gateways. So you can spread your workloads across workspaces and use different, multiple workspace gateways to make sure that you don't have a single point of failure in one API gateway. Okay, because if you still have one API gateway, there might be a failure caused by your own APIs, not by the infrastructure, but for example, your own API may cause exhaustion of CPU and memory and may cause an outage in the whole gateway for all the APIs. But if you distribute your APIs across workspaces and workspaces across multiple gateways, you don't have a single point of failure. You have multiple gateways that run different APIs. There is a question from Daniel. Will there be an in-place zero downtime upgrade from Premium to Premium V2 SKU? We don't have Shrikant on the call anymore. It is something that we are looking into. At the moment, we don't have an answer if there will be this automated in-place migration. We'll keep you posted as we progress on the journey and explore the feasibility of this solution. What I meant was, do the AI plugins generated by Cephal, etc., support high availability configuration? Yes. So high availability is for the API management service. It doesn't, from our standpoint, of course, you need to also ensure high availability of your backend services. It doesn't matter if you're using AI policies or if you're using some other policies or the method of deployment, CI/CD, whether you're using Bicep, ARM templates, PowerShell, API ops, etc. Doesn't matter. It's just part of the API management service configuration. So yes, it is supported, using Bicep and using AI policies. Hope that answers your questions, Daniel and John. We'll give it one more minute. If there is any more questions, please remember to provide us with feedback. Much appreciated. All right. Well, thank you very much for joining us today, and Happy New Year. We're going to see you in the new year. And please keep an eye on our blog for the official announcements.